NED Library, absolutely autonomous education. We are technocrats, astute entrepreneurs, and above all, passionate academics. We are education specialists, rendering learning solutions to schools, corporates, and government, such as a broad spectrum of digital learning environments. We are the bridge between students and teachers. Our role is complementary. Our focus area is the curriculum, how well suited it is to the industry's skills demands. Reading seemingly is a handicap. How well adjusted is the content to fit to the target audience? There is always a way for a fish to willingly take the bait.
Hi, my name is Zina Zerebwa from NED Library, and I'll be taking you through the process of photosynthesis, and I presume that you've done preliminary biology. So what I'll just do is to take it from the keywords. So you realize that as far as photosynthesis is concerned, we'll be looking into statements such as photo excitation, Hydrolysis, and then phosphorylation. And also, I believe that you have gotten to a point whereby you learned that photosynthesis is a process whereby we are converting light energy into chemical energy, which can be stored and used later, like in cases where there is no, when the sun is not shining, like the rainy days and stuff like that. So we're going to be getting to break it down to get to know exactly what happens. So mainly, you'll understand from our basic equation of photosynthesis that carbon dioxide plus the molecule of water will give us a glucose molecule, H2O6. As oxygen is evolved. So the next thing that we're going to do is to try and balance out our equation. And this is six molecules of water, and then this is 6. So we got 6, this is 612. So this is 6. Okay. So what we seek to do is to bring out an understanding of what exactly is going on. As you can see, you see that when 6 molecules of carbon dioxide reacts with 6 molecules of water, what we have is a molecule of one molecule of glucose that is produced. Now the question that we want to ask is, what exactly is going on? We can see that these are 6 cycles of you need 6 carbohydrates molecules in order to come up with one glucose molecule. So we need to understand from the key words that we have and exactly what will be going on. And before we get into the details of that, there are some other core factors that you encounter during the course, and maybe it's beneficial for you to get to know exactly what is happening. Like you come across this molecule that is called NADP+, and then its reduced state known as the NADH molecule, and then of course our favorite guy called ATP, and you can also find it in this form ADP. So what we seek to understand right now is what is happening as we're moving from this molecule that is called NADP to I've left out a P, NADPH. Okay. So from chemistry, you realize that there's an acronym that is known as LEO, And another one, gain of electrons, reduction. So when you are losing electrons, you call that oxidation. And when you are gaining electrons, you call that reduction. So I want to see what is happening during this process, where our molecule is changing from NADP to become NADPH. As you can look at this last end where you've got a P+, what it basically means is that this molecule has donated an electron. So in other words, it has lost an electron. So we are moving from this state coming to this other molecule. And what we have here in terms of oxidation state, this one is a +1. And this is meaning to say that this molecule has lost an electron. And this one, NADPH, the oxidation state is 0. And according to the rules of oxidation and reduction, you realize that when a molecule has lost an electron, it is oxidation. When it has gained an electron, we call that reduction. And also that when you are removing an electron out of a molecule, what you are doing is that you are oxidizing it. But if you are at the other instance, if you are removing a hydrogen atom from a molecule, in other words, what you have done is you have oxidized it. So basically, what is happening with this molecule, this particular molecule, is our oxidation state is changing from a +1 to become 0. So in other words, this is a decrease in our oxidation state. A decrease in oxidation number. So according to redox reaction, if a molecule has decreased in terms of its oxidation number, we call it reduction. We can also look at the molecule vice versa, like coming from the NADPH molecule, going back to NADP molecule. And you realize that you are starting from 0. Okay, let me wrap this and we'll come back later. You are starting from a state whereby its oxidation state is 0. And then you come to this NADP molecule, and what you have is a +1. So when you move from 0 to +1, in other words, you have increased in terms of your oxidation state. So this is what we call oxidation. Okay. So what we are saying, in other words, is that as your molecule, because this molecule is going to be involved in our reactions, as far as photosynthesis is concerned, these are called cofactors. It's not an enzyme, but it is a cofactor that works together with enzymes in order to give our desired effect. So what we have at the end of the day is when you have got such a molecule such as NADP plus coming to becoming an NADPH. In other words, this molecule has been reduced. So this is reduction, moving from NADP to NADPH. The process is known as reduction. And vice versa, if you're moving from your NADP molecule to NADP molecule, what has happened is oxidation. But now we want to understand, we need to know the function of these two molecules. What exactly do they do? As I shall get to do as I go on with my presentation, you realize that we call this NADP molecule. These are electrons carriers. They carry our electrons. They store energy, which will be used in later stages. As you know, photosynthesis has got two stages. So we're talking about the light-dependent stage and also the light-independent stage. Some people call it the dark stage, though it is not the dark stage in the sense that it can also happen during the light, but what it basically means is that it does not require light in order to pass through. Now the other molecule that we're looking into is ATP. our ATP and ADP. So you realize that ATP, okay, I'll get to do a slide that shows us the intricate details on the structure of the ATP as it is. But if you are moving from ATP to the molecule ADP, in other words, what you are saying is that you have lost a phosphate group. Like, check out this. We are saying that this is ATP. ATP meaning that adenosine triphosphate. Tri means 3. So this one is the molecule is made up of adenosine plus 3 groups of phosphate, and the other one, ADP molecule, is made of adenosine as well, and plus 2 groups of phosphate. So in other words, when how exactly this molecule works, this is a high energy molecule. In other words, it is very reactive, and the way it is grouped together in such a way that you've got this bonds joined together, the structures. So you've got your adenosine here, one phosphate group, another phosphate group, and then I would deliberately put a squiggly line here plus another P. The way these guys are arranged, they are arranged in such a way that they behave like 3 friends who do not like each other. So what is happening is they are fighting, waiting for an instance whereby they can kick the other one out. And so you realize that due to a process that is known as hydrolysis, hydrolysis is when you add water to the molecule of ATP. What happens is that this bond is broken, and when the bond is broken, and what we have at the end of the day is a molecule that is known as ADP, and the breaking of the bond by hydrolysis liberates energy, and that is how our cellular processes, that is how cells get energy that they need for cellular processes. So basically, this is it as far as explanation of the interesting molecules that we are going to be encountering during the course of the presentation. But now, before we get back into the nitty-gritties of the presentation, we have to try and to understand the meaning of the statements on the board. Our keywords, that is photo excitation, and then we're talking about photolysis, and then we're talking about photorelation, and basically this is English. These are concatenation of 2 words, as you can see. Photo something, photo something, and from your early studies, I understand that you know photo means light. So photo excitation, in other words, we're saying that this is a movement or gain in terms of your kinetic energy that comes about as a result of light coming in contact with a certain object. And then photolysis, photo still is talking about light, and lysis is death, destruction. So this is the destruction that happens to a certain molecule due to exposure to light. And then this should sound familiar from the last presentation, from the last statement that we were talking about. We spoke on the issue of ATP molecule. It contains a group that is known as the phosphate. So as you are saying photophosphorylation, you are saying that it is a process that came about as a result of the work of light bringing about the addition of a phosphate group on a certain molecule. So that is it as far as our interesting terms and molecules that we are going to be encountering during the presentation is concerned. Now we're taking it off from the presentation that we have. There's nothing hectic about just the introduction. What we are talking about, what I will do is just to to write down some of the things that are on the presentation, and then we'll go back onto the presentation and begin to break it down according to the points on the presentation. You realize that when you talk about photosynthesis, the first thing that you should think about is the issue of the site for photosynthesis. Where exactly does photosynthesis happen? And the next thing that you need to know is what are the stages involved as far as the process photosynthesis is concerned. So, as shown by on the overview, you realize that your site for photosynthesis is your chloroplast, and from the earlier stages, maybe one of the things that we knew was just from the equation. We knew that when carbon dioxide reacts with oxygen, what we get at the end of the day is a molecule of glucose plus oxygen, which is given off. This is what we knew. And most of the times we eliminated the intricate details, such as the light, which is our source of ATP, and the issues of enzymes. Because photosynthesis, as it is a process, is an enzymatic process in the sense that you need enzymes in order to come about with the desired result at the end of the day. So this is what we want to get into. Like I remember the others, you would talk of chlorophyll. Chlorophyll, yeah, is one of the substances influencing the process of photosynthesis. So now what we are talking about is we want to zoom into the issue of the site of the photosynthesis, where our photosynthesis happens. So in other words, you're looking into your chloroplast. What exactly is your chloroplast? You realize that chloroplast is an organ which contains some other structures within it, such as you talk of your thylakoid, and these are arranged in stacks of groups of three thylakoids. They make up what is known as a granum, and this is a stack. And your thylakoid is the interesting guy that we would love to talk about as far as photosynthesis is concerned, where you find your green pigment, which is your chlorophyll. More of the details we shall delve into it. And then the other structure found in the chloroplast is your stroma. And what is your stroma? Your stroma is colorless and filled of liquid. Okay. So now we want to understand, like the next point was what are the stages of photosynthesis? And according to the study on cells, that must be chapter number 2 in biology, if I'm not mistaken. You begin to realize that the structure of a tissue, an organ, or a cell determines its function. So we have managed to explain that the thylakoid organelle is made up of chlorophyll. It contains chlorophyll, and then the stroma is filled up with liquid. We need to understand the reason as to why it is like that. And then you begin to appreciate that your photosynthesis has got 2 stages. That is what is known as your light-dependent stage, and the dark stage. The right statement there rather is light-independent stage. It doesn't really require light. light independent. From the scenarios that we are having on the board, something should ring a bell. Like we say that the structure of a cell determines its function. And right now we'll say that photosynthesis, the stages of photosynthesis are 2, and the structures that we have narrowed down as far as the chloroplast is concerned, so we have tried on the issue of the thylakoid and the the stroma. So in other words, one of this structure has got something to do with the light-dependent stage, and the same can be said as far as stroma is concerned. So you realize that our thylakoid deals with our light-dependent stage, and then in the same vein, our stroma does with the light-independent stage. Before we get back into the presentation, we want to get to know the reason as to why it is so. This has got to do with the way your thylakoid was configured. You realize that it's got that green pigment known as chlorophyll. And what are the characteristics of the green pigment? You realize that chlorophyll has got a high affinity for light. So thylakoid, the structure, its main function has got to do with trapping light. And whatever happens after it has trapped the light is what we are going to know about. And I understand also that you have learned that most of the processes, metabolic reactions, they occur in the cytoplasm. That is why the stroma is filled with liquid. Having said that, we can move on to our PowerPoint presentation. We are done with the introduction.